Hello, welcome to ANS Solver. This is the sixth question of the paper. So I need to solve this equation which is sec alpha cosec alpha equals to 7. So I'll make a column here for all the trigo identities because this question will involve a lot of trigo identities. So the first trigo identity I need to know is that sec x, just writing x for now, sec x, sec alpha, whatever, can be written as 1 over cos x. Okay, and cosec x can be written as 1 over sin x. So implementing these identities, I can write this as 1 over cos x into 1 over sin x is equal to 7. So I can basically write this as 1 over cos x sin x is equal to 7. Now what do? Am I trapped? I don't think so. What I can do is, I know one trigo identity which tells me sin 2x is equal to 2 sin x cos x. Agreed? So if I make sin x cos x the subject of the formula, I can write this as sin 2x by 2. So I can basically write this as 1 over sin 2x by 2, which is equal to 7, which I can basically write as 2 over sin 2x equals to 7, which I can simply write it as sin 2x equals to 2 over 7. Now I need sin to be positive. Okay, ASTC. So sin is positive in the first quadrant and in the second quadrant. So what I can do is, I know I need to maintain the degree mode because 0 degrees to 90 degrees, correct? So I can simply do sine inverse, okay? First make sure you're on a degree mode, sine inverse of 2 over 7. When I solve this on the Calc C, I get this as 16.601, comma, if this is theta, to calculate the second quadrant, we do 180 minus theta, correct? Basic trigo, so I do 180 minus 16.601, which gives me 163.39. So I get my x basically as 16.601 over 2, which gives me 8.3 degrees, comma 163.39 over 2, okay, gives me 81.7 degrees. So these are your final answers as it's lying in the range of 0 degrees to 90 degrees. Now the B part, showing all necessary working, solve the equation. So for this we need to know two compound angle formulas. The sine compound angle formula, which states that sine A plus B can be written as sine A cos B plus sine B cos A. Okay, and my sine A minus B compound angle formula, which can be written as sine A cos B minus sine B cos A. So now implementing these compound angle formulas, I know this is sine beta plus 20, which I can write as sine beta, okay, cos 20 degrees plus sine 20 degrees, okay, cos beta, okay, plus now I can use my sine A minus B formula, which gives me basically sine B cos 20 degrees minus sine 20 cos B or beta, which is equal to 6 cos beta. Agreed? Now I can simply say I can cancel off both of this, correct? So, and when I add this and this, I get 2 sine beta cos 20 degrees, which is equal to 6 cos beta, correct? So now what I can simply do is I can cut 2 1s are 2, 2 3s are 6. Got it? So I can simply write this as sine beta over cos beta is equal to 3 over cos 20 degrees. Got it? I know cos 20 is, a value of, a basic constant. So I can write this as tan beta is equal to, I know cos 20, if you solve on the calci in the degree mode, I simply get this as 0.93, which I know is a normal constant. So let me just write it as 3 over cos 20 so that we don't do premature rounding. Now I need tan to be positive. So tan is positive in, your ASTC. Tan is positive in the first quadrant and the third quadrant. So I have theta for this and I have 180 plus theta for this. So I simply do tan inverse of 3 over cos 20 degrees. Okay. When I solve this on the calci, I get my answer 72.607, comma 180 plus theta is simply 180 plus 72.607, which gives you 252.607. But if you see, your domain is 0 degrees to 90 degrees. So that means this answer here will be eliminated. So your final answer is simply 72.6 degrees. Got it?